I'm happy to be here. And this time, I'm not going to talk about CTRE or any template magic ever. So be prepared. This is casual C++. So I'm Hana. I'm Czech National Body in ISO C++ committee. I'm also Reflection Study Group chair. And I'm also author of CTRE. You won't listen about it, anything about it. And also, I'm staff scientist at GEN, which is for Avast and Norton LifeLock. And code you are going to see in this presentation, it's C++23, mostly. It's still slideware, so it's not guaranteed it will work. And there is a lot of things missing, like parsing and dependencies. You don't need to care about it. And also, everything is in namespace Luna, because I like the name. And I'm using a Firacode font. It's awesome. You should use it. And it contains ledgers, so don't be surprised. There is different. Sorry? OK. OK, the premise of this talk is I need to update an object on tens of millions of our clients whenever I want and quickly. In Avast, we had tens of millions of clients, and we need to push update to it when there is a new threat detected. We need to push to our clients as fast as possible to make our clients secure. So this is the premise. So Lightning updates. What can you update? Raise hand if you are caring about updating of your application in your work. OK, only. Okay. And how do you do that? Oh, what you are updating? Executable, content, state of the application, some setting. And the state of the application which you are updating should be immutable, because it's something you are pushing to clients. It's not something which users should change somehow. And also, it should be consistent and secure. So you don't want any user to mess up with the content. And also, the state is obviously data structure. Everything is data structure, some sort of dictionary, tree, or anything. And the data structure can be represented as a file, binary, textual. It contains your data, because it's data structure. And is the subject of your update system. So whatever you're updating, it's some sort of data structure. Even executable file is a data structure. So updating mechanism can be just replace everything. Just send email to your clients. You need to download this and replace it. OK. It can be additional. So your application or some script will download something, and it will add something to your storage, and it's just overlay. It can be differential update. You will applying patches. And how many of you know OTA, over-the-air updates, especially with mobile phones? You want your application to be updated as fast as possible, as often as possible, to be secure and everything. So we can say that state n+1 is just state and difference between these two states. And difference is just a cell in a matrix. So you can represent different states of your application as a matrix, and each cell is just different. Or you can express the matrix as an update graph. So your application is in state A, or then you update into state B, and C, D, E. But usually, you don't want your client to update between all versions slowly. Sometimes your client turn your PC on only once in a month. So you want to have some shortcut in the graph, like this, like this, like this, or maybe even longer. So how do you find path between A and E? This is obviously the shortest one, because you see the graph. It's easy, because you just look at it and done. But if it's between A and D, you need to take 2 steps. OK, but if you don't know the graph, you have only state your application is in, or the old version, B, and you are supposed to update to latest one, E. How do you do that? Because you don't know the graph. You cannot go forward from your previous state and just somehow find about future update, because your application doesn't know the information, because past cannot change. You can only change something in future. So you need to go backward. You will download the latest update, look backward to which point in time it connects, and then find the best node and download it, and from that find connection to your current state. Okay, that's easy. Okay, but how do you represent the link between states? And we are slowly going into C++, but still not there yet. You can call it as a file name with version number or name of the release, or the node. The node is ABC, and the link is AB, BC, and etc. Or it can be identified by its content. It can be hash of its content, like secure hash, like not MD1, obviously, or MD5, or SH1, no, SH256 is OK. And then it gives you a nice property, because in your mind, you can say that hash value of the content is a pointer to the content. It's unique value for the content. The content is immutable. It cannot be changed. So it's like persistent. So you can actually, it's called content addressable. If you know the hash, you can always get the content. Also, it gives you data immutability. If you change your data, it will get different hash. And if you download broken file somehow, you can check it, and the content, if it's changed, it doesn't match your hash, and it's wrong. And it's really easy to cache because it's immutable, it's persistent. You just place it into cache and don't care about, and forget about it. It's there forever, kinda. And also gives you transitive trust. So if you know hash of A, and A points at B in its data, and B points to C, by downloading data, you can actually trust the C, especially if the A is somehow signed. So let's have multiple states as a graph, BCE. Your application, just names of your versions, let's say. But actually, in the graph, you don't have the states of the application, because it can be several hundred megabytes. You have only metadata describing the state. And the metadata can be only 10, maybe 100 bytes long. And they contain information about previous updates or states. Contain information like hash of your subject. So you have data structure, like maybe vector or hash map or whatever, or tree. And you can calculate hash of it. So whenever you update, you can actually check the content you updated to against metadata you are in. And metadata contains also, or can contain, signature. And actually, links between various states are deltas. It's always delta between C and E. There is a delta C and E, and also copy of metadata of C. Because they are small, so there is a dashed line between them. And there is a snapshot. Some states in the graph can contain a link to a snapshot, which is serialized subject you are updating. But not every metadata or every state needs them. So let's say, OK, we will get there. So if you have a snapshot B, you can unpack it and get subject B, obviously. And if you have subject B and apply delta between B and C and delta between C and E, you can get subject E. So if you unpack snapshot B, apply delta, you can get subject E. So there is no need, if you creating your updates for your application every few minutes, you don't need to create snapshot of whole state every few minutes because it's a lot of data. You can do it only once a day. So let's say there is update graph, and we are in state C, which means, but we are updating to C, and application is an empty state. You don't know anything. We just got the metadata somehow. So you need to find path to closest snapshot. There is only one link, so download delta. By that, you will get state B. Then you download data to state A. And from state A, you can actually download snapshot, unpack it, get subject A, apply a delta, get subject B, apply another delta, get subject C. And that's how you update from nothing to something. OK. And you need to model this graph and the algorithm with vocabulary types. Whenever you are modeling any algorithm, you need to think about what's your vocabulary. So first, nonce, values. Hash, I talk about hash. We can represent hash as stat array of bytes, and hash view is just span of bytes of certain size. But it's just alias, and I don't like using generic type for something which has a meaning. And in this code, hash or hash view has a meaning, and it shouldn't be mixed with other arrays of bytes. So let's create hash. There are some constructors, some friend operators for comparison, some iterators for begin end, so it's range, const iterations, and the hash view is the same, but it's based on span, and etc., etc. It's a lot of code, and you can get it wrong. And I think the best code is the code you won't write. So what about using inheritance? Let's make hash of certain size to inherit from stat array. You will get all the function which is in array, and you can just implement whatever is something special for your type. You name it, you mark it as a super type, and then by using super, you will just bring all constructors of stat array forward, so they are at the same level as your special constructor, which is explicit because it's materializing something from hash view, and it will just take ranges, create initialized copy from the original, from the view into itself, and you are done. You don't need anything else. You have comparison, you have iteration, everything. Span, hash view is exactly the same. You inherit from span. Also, bring the constructors forward. Create explicit constructor from hash because it's cheap, because it's just view, and just take the original value and push it into span constructor. But span is not comparable. Thanks, 21 years, I can name. So we need to implement our comparison. So friend operator, three-way, and just use ranges lexicographical compare three-way, and you are done. Same thing for equality. Okay, and tagged hash, we can build forward. We can create layers. So we had hash value, so we can create tagged hash, which is not specified by length, but some tag. So we create hash, takes constructor forward, create new constructor from hash view of same tag. Same for hash view. We will just inherit from everything. And then we can create tags for sh1, for sh256. And now we have special hash value for sh1, sh256, and view for them. And then they won't mix. We can also create aliases, so we don't need to use the long type. But here, alias is OK. So in your code, if you have array and span, you can always implicitly convert to span, because it's a view. Same thing applies for hash value and hash view. From hash value, you can always create hash view, but not in opposite direction. Also, tagged value and tagged view work same. you can always degrade tag value to hash value, because hash of certain size is superset of hash of that size, but with meaning. But you cannot go up. You cannot implicitly upgrade some random hash into sh1 because it's different meaning. Explicitly, you can do that, but it will be documented in your code. As Tony said, strong types create strong code. So yeah, it's the same error as last time. We have another noun, sorry. Metadata in our graph, the small one, contains hash of the subject it points to, subject you are supposed to update to. And also it contains color of the graph, so you can actually distinct two different graphs of different colors, so you want to mix them. Maybe we decide to create a totally unrelated graph, so your clients need to be able to detect it. And then also there is a time point of UTC time when the metadata was created. It's important. And then there is a list or vector of links to deltas in past. And also optionally there can be snapshot, link to snapshot based on its hash. Okay, and the metadata, but these two members are not serialized, contains its hash. Like they are identified by it, and it's useful to have it. And also, it's useful to have the whole content of the metadata as serialized as a bytes. We will get there. So delta link is pointing to past, to some time when previous metadata were created, and also hash of the object you can download. And also distance to closest snapshot. It's number of jumps or number of bytes you need to download, doesn't matter. And also comparisons, so you can compare them by default, because compiler can do that for you. You just tell them, yeah, I want this comparable, and yeah. Okay. So delta, it's really simple type. It's just metadata of previous metadata, previous state. I'm using state and metadata as like interchangeable. And also bytes of the patch itself. I don't know what's the format of the patch, I don't care. And snapshot is just vector of bytes of something which then I will unpack somehow. We will get there. So we have metadata, we have delta, we have snapshot. And now we have identifier, which is just tagged hash of our crypto function of choosing, let's say sh1, and type of the object. So it's like hash of the object and let's say extension or name of like metadata, this is delta or something. We can compare it only by type, against type we can compare it. And also we can serialize it with, we can concatenate it with string view. So we can actually prepend with like a web server address from where you will be downloading the object. So you can provide, let's say in our case, it's abcdn.net/, and it will append and gives you string with the URL you want to download with your favorite library. And we have type, metadata, snapshot, delta, and there is alias type. This is something special, because every object in the graph until now was identified by its hash, so it's immutable. But sometimes you don't want everything immutable. We have the graph, and sometimes you want to mark something as the beta version and something as a stable version, because you want to have different groups of users on different versions. But every time you update it, you need to actually somehow mutate the alias. So if I update stable version to same version as beta, because it was proven it's good, there are no bugs, you can, let's go. I need to change the alias somehow. So the alias is not stored under its name. It's stored under its name, like maybe a latest.alias or somewhere. Or it can be, but it cannot be hash of the content, because it will change. So it's a hash of the name, because everything is stored under its hash to make everything simple. So it's just take name, latest, and hash it, and you will get some bytes, and that's your name. And because that different identifier gives you file object type, you can actually make your web server or CDN, content delivery network, special cache rule for Alias, that it's not cache forever, but only a few minutes. Okay. Now we got some bytes we download from internet, from the web server. We need to deserialize somehow into object. But we don't know what is it. So we need to create something more special. Any object, like stat any, but only for our object. So it's variant of metadata, delta, or snapshot. Alias is just copy of metadata. So we will take constructors, obviously, and then there is like access, there is like, it's called, I just forgot the name. In C++23, you can actually access itself as self. It's like special C++23 type. And yeah. And if the object is metadata, it will give you pointer to the metadata. It will give you the type pointing. Otherwise, it will be null. If the object itself is delta or snapshot, it will give you what you need. So, and then we use protobuf. I don't know what to use. We can use JSON, XML. Just please don't use YAML. In protobuf, first thing you wrap, like serialize. You need to tell us what's the type, and then store various type if it's metadata, patch, snapshot, and if there is a signature, then there is that also. Okay, we have nonce. Now here we have verbs. Verbs are function algorithms. So we will take identifier and some data we just downloaded, and we return any object. How do you do that? Somehow we deserialize it with protobuf, or some library of your choosing, and you will get something more C++y. And if the type itself is metadata and contain metadata, and every metadata needs to contain signature, you will validate the metadata and return to client as any object with ID and the metadata signature content, and etc. If it's delta, as I showed, needs to contain metadata and the patch. Then you validate the delta against metadata and patch and return to client. And if it's a snapshot, you will do the same. If there are snapshot present and is the type correct one, otherwise you will throw exception. It's invalid object. Okay, so we got metadata. We have identifier and span of bytes, the content of the metadata, content of signature, and content of the whole wrapper, including signature and everything. And we will return metadata. So if the ID we ask for is not metadata or alias, then you're obviously asking for something else. You shouldn't be here. Then you can calculate hash of the content itself without signature, just the content of the metadata. And if ID is metadata and hash is not matching against what you are asked for, then your checksum is not matching. It's wrong. But if you ask for alias, we will get there actually. Yeah. And then we will validate signature, which is special case for aliases, because aliases can have different hash than we downloaded. So we need to validate signature against trusted keys, against our hash and signature. Otherwise, it's problematic and we need to throw away. And then we can be sure that our content is authentic and it's correct. So we can deserialize the metadata itself and get the result. And into result, we store also the hash. We calculate it because it's same, but it's not inside of the hash because it's hard to calculate hash of something which contains the hash. And then we also wrap the original bytes. We just take the view, and with ranges 2, we materialize into vector of bytes. And return metadata. OK. And then how we validate delta? We will take identifier, span of metadata bytes, batch bytes, and return delta. So if the type is not delta, obviously, wrong type. And then we calculate, concatenate a hash of the metadata and patch. And if the hash doesn't match against what we ask for, again, exception. And then we deserialize the metadata. It's just protobuf again in protobuf. And then store metadata hash into metadata. There is no signature. There doesn't need to be any signature. And then we return delta, which is just previous metadata we got by deserialization, and we materialize the patch itself from what we download and return it. Snapshot is the easiest one. Identifier, content, and if the identifier doesn't match, then we calculate hash, if the hash doesn't match. And snapshot is just a bunch of bytes without meaning for now. We are giving it meaning with type. So we have basic verbs, and we have graph, we represent objects. And now we are going into C++ again. And how do you represent it in memory? You have graph, and you are in some certain state, let's say in C. So you actually own the subject C somehow. It's some data structure. So you actually somehow point at it. From perspective of your computer, it's just like this. You have application, which points at state, and state points at subject. Subject is data structure. And when you update, the pointer just changed to different state, and previous state and subject is just released. And then you update again. You are in another state, you release the old one. How do you do that? You create state type, which is metadata you are in, subject you are in. Everything is const because nothing is mutable. You will create it once, and you will never change it. There are some functions to, and it's shared pointer. That's important. It's a shared pointer because you will be sharing the state with application. I will show you. There are some functions which will give you hash of current state, which is hash of metadata you are in, color of your current graph, and timestamp of your current state you are in. So why shared pointer? How many of you don't like using shared pointer? Why? Shared pointer is awesome, but shared pointer of const t is awesome. Because if you have shared pointer of something, it's shared over multiple places, or even worse, multiple threads. You can change it, and it's just a headache. But shared pointer of const t is value type. It's resource. It's immutable, and it can be shared freely. And internally, it's atomic. The counter is atomic, so you can share it between threads safely. And also, it cannot form a cycle. You cannot create cycle of shared pointer of const t, so it will never leak. It behaves as immutable type, so you don't need any locking to access it. You can just read it. It's safe. And also, it's safe memory if you are working with a large object, because in update system, you can work with a few kilobytes, also with a few hundred megabytes, and you don't want to copy or move 100 megabytes. So we have state, and we are going forward to update mechanism. So let's say your application is in state B. You have some information about some previous state A, and somehow your application is triggered to update into state G. We already do that. So you download the metadata of G. By it, you will get information about previous states directly connected to G, like E and F. But how do you select now which state or subject metadata you need to download? you are going into past, and you want to select the node which is the closest one by time to your node you already own. Because you need to have one guarantee in the graph that there is always path -1 to previous one, the shortest one that needs to be there. And then the algorithm is really easy. You will choose the closest node to node you are going to. So in this case, it's E. Because they are sorted by time. It's not actually a really complex graph. It's actually skip list, if you think about it. And now you will choose C. Because there is a timestamp, and you cannot you actually cannot, it's published from only one place. So you will never create two nodes which were published in the same time. So you can count on that they are sorted by time and there are no collisions. So you will choose C. And from C, you will find direct connection to state you are already in. So you are connect, and this is whole graph. We could choose different path. There are multiple paths to get there, but this one is the most efficient to find if you don't know the graph, because you need to think about amount of data you are downloading. So how do you select next path in graph? You will get metadata. That's metadata you just download, and shared pointer of current state, and the function will return identifier of next object to be downloaded. So if you are in some state, if it's not empty, you need to check the color of the graph. If the graph is different color, it counts like you are in empty state. You need to, for purposes of this function or algorithms, you just mark your state as empty because you are doing actually full update. And if you are still in same state, just like sanity check, you need to check that someone is not forcing you to downgrade. Because if someone is forcing you to downgrade, this algorithm won't work. It's going only in one direction. So if someone is forcing you to downgrade, it's full update again. But your metadata should contain snapshot, hash, or at least one delta link. Otherwise, the precondition of the graph is wrong and everything will fail. So if you are in empty state, you are doing full update, and there are no delta to go, so there must be obviously the snapshot, then you will return identifier of the snapshot to download, because you have it in your metadata. But if you are doing only partial update, you will look at the delta links, filter them with ranges. I don't know if it's a great idea, listening to this morning talk from Nico. And you will choose only the eligible one. And eligible one means that the timestamp is larger of the target link than your current state. So you won't go behind your state. And then you sort them, return the, not sort them, you return the lowest one, and they are sorted by the timestamp. And you will return hash of the closest node in the graph and its type of delta. And you will return this to the color. But if there are no delta links, sorry. But if you are going to close the snapshot, you will also look at delta links. But you will sort them by, what's going on here? By operator less, and you will provide projection to distance to snapshot. So it will be sorted by the distance to snapshot and not by the timestamp. So we'll look for least amount of data you need to download or number of jumps, whatever you fill when you create the update. And then you will return path to delta. because you are doing full update in this case. Okay, so path and objects. Path is just vector of any object. That's the path in the graph. So you can create function which will take identifier, and it will give you any object. It will be some magic function. Probably there will be some library like curl, which will download it for you. It's specific for a platform, so you shouldn't care. And then there is a function which will convert the object based on an identifier and based on provided callable, which will asynchronously fetch a vector of bytes, and it gives you. You will call the callable, and it will give you a coroutine, in this case, call task, which will give you an object. So an async fetch is just the object must be invocable with identifier, and it will give you something you can await on a table of. So you will fetch bytes. You will call the please download me this identifier, this object, this hash, this extension from this web server, whatever. It will give you coroutine you can await on, so you will await on it until it's downloaded. And then it will unwrap and validate the object and return, because this is just coroutine, it will give you object. So it's a coroutine task returning any object. It will download it for you and unwrap it or throw exception. So download is just take identifier, use this, and it will give you a task returning vector of all objects you needed to download, or bytes in this case. Vector of bytes, sorry. Yeah, I'm a little bit forward. It will give you a vector of bytes you download, and that's something like you will integrate with curl, with iOS, get fetch content, whatever. So fetch path. I'm in some current state, which is by value, it's copy of current state. And I'm having some target of my update, hash or name, if it's alias. And I'm providing from outside as a user callable which will return a coroutine which will download vector of bytes. And I will return task which will give user vector of objects from the graph. So the path at start is empty. And then I will use this small lambda to wrap everything together. So I will take the callable, provide it as callable into convert to object with ID, and return a task for any object, as I showed on previous slide. Then, if I'm doing non-partial update, and my hash of my current state is same as target, then I will return empty path because I don't need to update to anything. Because someone asked me to update to point I'm already in. And then, if not, I need to convert the target. It's a hash, it's variant of hash or name into identifier. Then I will call fetch object. Please download this for me. I will await for it. And I will get the object from this function. And then I can place it onto path, which is first step on my path for the update. And then there will be infinite cycle. I will look at the last step of the path. And if it's metadata, and I'm doing full update, and the metadata I download are my target state, target node, I will finish because I found a path to where I want to go. Otherwise, I will look which object I need to download next from the metadata I got and current state. Fetch the object, wait for it, and place it at the vector of objects. If it's delta, I will just unwrap it, take the previous metadata from the delta and place on the path, so I can do the previous part of the code. And if it's a snapshot, I will just return a path, because snapshot means I actually did full update. And in case the select next function here decide I need to do full update because it found out it's a different color or something, the current state will be changed to empty, so it will switch to full update. And it will find the path to snapshot. OK, so we have path, and we have some state. And state is just application of the path between two states, whatever on the graph. So it's always state, delta, 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 and metadata at the end. Because it's the path we got is actually in reverse. We went backward in time. So we are doing reverse from the right. So why I'm using all of this? My application is in some state, and there is a subject. And I'm using SharePoint, or not SharePoint, let's say a reference in here. And I start an update. I will copy the state. I will download delta. I will download another subject, apply it, and will get new subject. And then I apply another one. And then when I'm finished, I switch application to different state. So until I'm finished, and it can be even in multiple threads, your application can be doing update safely. And only when it's correct, checked everything, then it switched atomically. So update2 function takes atomic share pointer of current state, const state, hash or name of target, which is just variant, the function which will return coroutine, which is downloading for you, and it gives you update result. So we load atomically previous state, because we have reference to it. We fetch whole path between target and current state with the callable. We await for it because we need to finish it. Then we will pipe it into fault right, because we are doing it from right, which is like something like accumulate, but in an NG's world. And fault right is doing from other side and normal accumulate. And we use old state and apply something like update traits. We will get there. It's functor, which will help us to apply something on our old state to get new state. And when, if the old state is null pointer or new state is same as old hash, we just tell user you already updated to latest version. You don't need to do anything. But otherwise, we will store new state and tell user it's updated. So update traits. It's just some structure. We need to apply and some update traits. I will show you. And traits is just some type. State is share pointer, just to make it shorter to fit inside. And if we get snapshot, then there is operator of state and snapshot. And such operation will just overwrite previous state and create shared state from const state, deserialize it, and provide empty metadata, because we don't have any metadata yet. And it will give you new state based on the subject, snapshot. Which means you are doing full update, and you just started. If it's delta, and you have some previous state, you will take previous subject, because there should be some. Take the patch bytes from delta, call traits, which you provide for your data structure, apply the patch, give empty metadata, because you still don't have any metadata, and wrap it into share pointer and return it. And if it's metadata you got, which are always at the end of the right fold, because you started with metadata, you calculate hash of the previous subject you are currently building. And if it doesn't match what you are expected to have, then there was some problem during the update, and you should throw exception. Otherwise, you will just take the previous subject, and because it's SharePoint, you just can take it. Metadata you just got, and provide new SharePointer of const state, and you are finished, you are updated. So update traits looks like this. There is a function, calculate hash of subject, because your data structure can be vector of bytes, vector of ints, it can be hash map, it can be dictionary. So I don't know how you calculate hash of it. It needs to be stable. So you, as a user of the library, you need to provide it. You will get hash. Then you can calculate difference when you are building it. So you have two different subjects and return vector of bytes. Because this is only place you, in the code which needs to understand of, the patch format, which is specific for your data structure. And then you need to provide function to apply difference. So we'll take previous subject, some bytes of the patch, and apply it, and you will get new subject. And that is also serialization support, so you can actually take subject and serialize it, or deserialize it and get subject. So that's the internal of the library. I'm getting late. So when you are updating, then there is a task in your application which needs the data you are updating, the subject. So it references it. And then you finish the update. We will do the update, and then you finish it. Suddenly, your task, which is maybe in different thread working, is dangling, which is UB and stable. That's the reason I'm using SharePointer, because it will never dangle. And you can, meanwhile, you can start another task which will get the latest data, and then when it's finished, the previous one. Then. So you should always take some like a handle SharePointer of some resources you are using, and release it when you are done. If you are just using reference, especially across the threads, you are screwed. So stream, you are updating. It's some type you are updating. It's like your type. It's like your dictionary, your configuration, whatever. And you provide update traits, how to update it. You hold the atomic SharePointer of current state. And there is a function update to. You provide target and function to download it. And it will give you success. Then there is also function get, which will give you SharePointer of current state. If there is no state, it's null pointer. If there is no subject, it will return null pointer. But if there is something, it will give you SharePointer to the subject. And you need to hold it as long as you need it. Then there is a serialization, so it will take state, current one, including metadata, serialize it, and you can store it to persistent storage. So your application will remember what it downloaded, so you don't need to do full update every time. Serialization, it's the same, but you need to, in this case, you provide the state. So if the state is empty, throw exception. But if there is a state, it will always contain metadata with original bytes, including this signature, which is needed because you want to check it. So you will take original bytes, you will serialize the subject with update traits, concatenate them, store them. Deserialization is similar. You will take bytes, and if it's empty, you won't get any state. Then you split somehow the metadata and the subject. You will create path from them, snapshot of the content you serialize, and you will take the metadata, unwrap it, validate it, and place it on path. And then you just apply the path, but from the left in this time. So you will take the empty state, the path with two objects, and apply the update traits, and you did full update when your application started from the persistent storage on your device. Then there is a constructor, and your constructor can take optional of the persistent storage if there is any. And if there is any, it will try to load it. And that's the application. And how it's used, let's say you have stream of dictionary with some traits to update it. You will download, or you will load file from persistent storage, provide function to download it with curl, and if you are updated, you will store it again. So every time you update, you will store it so you can start again next time. And then you will wait at the start of the application to finish the update every time. You can have some scheduler which will do update every 10 minutes. And then every time you do something, you will just ask for a handle and do something with the handle. So the essential part is that you have stream of some type, and you provide some traits, like in this case, bsdiff over bytes, because it's just bsdiff. And when you do something with your subject, you need to always ask for the handle and store it as a handle. That's like one thing you should remember if you do any programming. It's always to have a handle and use RIA. Release acquisition is initialization. bsdiff is vector and view bytes, calculate hash. You can calculate hash, calculate difference. You can apply the difference. You can serialize it with an ng's, and the serialize it is just copy. So at the start of the talk, I said, I need to update an object on tens of millions of clients quickly and whenever I want. I lied. I won't tell you how we are doing it. I just showed you this. Because the problem is now you just need to deliver hash value, 32 bytes, to all your clients, and then they will do the update on themselves. So actually, the problem is much simpler. You just need to deliver information about the latest update. So I showed you how you model algorithm into code, verbs and nouns. That strong types makes your code really easy to reason about. The code is really simple. You can easily test it and everything. And also, modern C++ is fun. And how do you use it, such library? You can obviously use to distribution AV signatures, as we do. You can synchronize configuration across clusters. You can do OTA, content updating of any application, maybe some game, many more. Let's say there's like you have map of file system path and content of the files, vector of bytes, virtual file system, and you create virtual file system traits. So you have how you calculate hash of the file system is that you calculate hash of all the objects and their names, and you calculate hash of all the hashes. Difference is similar. You just calculate difference between existence of files, and then over the files, you check if it's additional, removal, update, and if it's update, you calculate a difference with bsdiff or something else. And then you serialize it, compress it. Applying difference is similar. You just serialize the patch, check if it's valid, and if it's not, you will copy previous subject and apply all the changes. And this is actually a good place to have like copy on write if you have like really big files or really big types. And if it's addition, you just add a new file into virtual file system. If it's removal, you remove it. If it's update, you will apply the bsdiff. And that's all. And if it's a problem, you will throw exception. Serialization is just serialize everything and compress it. The serialization is same. Obvious, and that's how you make simple Git. Thank you. Any question? I hope there is at least one. Hi. Sound is not working? Okay.
Good. Oh. Okay, I'll stay a bit away.
It's scary.
Yeah, exactly. Good talk. I had a question about the motivation that led you to write this thing in the first place. Like, have you looked at other content and update delivery system? Did you find shortcomings, or?
When you're updating tens of millions of clients, you need to do it as efficiently as possible and as quickly, especially if you actually want to distribute AV signatures. Seconds matter.
Right.
20 seconds means like maybe 5 million clients could get infected. So you need to be really fast.
Right. And anything else you looked at? Like, I don't know if there are any existing like solutions.
We had like multiple solutions historically. I'm not sure if I can talk about them. Some of them are in use. There was like different types of updates, like overlays, complete changes, or patches. And most update system you see in Wild, they are working on files. You will update file and then you reload it. But if you are doing it quite often, like every 2-3 minutes, you don't want your like all clients, even with slow computers, to reload 100 megabyte file. You want to do it as efficiently as possible in memory, if possible, copy on write, so it only small change of the data structure is changed, and that's how. And because also many update systems focus on updating the files, they are designing everything around files. But I ask question, what does it mean to update? And if you want to update anything like data structure, you need to like compartment. Oh, sorry, I cannot pronounce it. You need to like distinct two things: updating, and there is also downloading, and your data structure. It can be different. It can be different for each component, and you don't want to copy your code multiple times. So you have templated code which will do all updating for you, and you as a user, I mean programmer of some component which needs to be updated, only need to care of like placing one line of code. There will be my data structure stored, and this is how I get the handle to it. And everything else is taken care for you.
Okay, I see. No, it's really good.
Thank you. Okay, you can find me here if you are shy to talk publicly, or not, do whatever you want. Thank you.